So from today we are going to start coverage and assertions. So till now we have completed OOPS concept and randomization, all concepts in system Verilog, right? So leftover topics are coverage and assertions. So these are 8 days sessions anyway, alternate days, right? So first day we are going to discuss on introduction to code coverage and functional coverage. Okay, so in that subtopics or what is meant by coverage and what is the importance of coverage and the detailed explanation of different types of coverage and how in SOC level or in IP level, like whether in system verilog or UBM verification, how the coverage analysis can be done, and what are the different steps we need to follow to report the coverage, okay, to get the report of coverage, like how many number of bins are hitted and how many holes are there and what is the coverage report, how much percentage we got the coverage from analysis. So all these things we are going to discuss in day one. And next, code coverage. So as I told, in coverage there are different types: code coverage and functional coverage, or toggle coverage, assertion coverage. There are different types. Okay, so in the code coverage we need to look into block. So how we are going to write in a block level or statement or expression. So detailedly we are going to discuss what is meant by code coverage and how to improve, and factors to improve the code coverage. Okay, and next, question and answer discussion, lab sessions, and also how the logical codes can be written for code coverage and syntaxes we need to follow, and how we can write um, different blocks. Okay, different logical questions. Okay, and next, fourth day is for functional coverage, detailed explanation on functional coverage and factors that affect the functional coverage, and what are the different types of coverage are there, like how many number of ways we can write the bins. Okay, so that thing we are going to discuss. And in fifth session, like same, how many number of bits are there, bins are there, and problem statements and some of the interview questions in code coverage and functional coverage. And next, assertion based verification in system verilog. One of the most important topic is assertions. Okay, so how to create the assertions, mainly what is the use of assertion in validating the design. Okay, and what are the different tasks, and there are some system tasks in assertions. Okay, so we are going to discuss those things detailedly. And the lab sessions on assertions. So what are the use cases and how we can write different types of assertions, like immediate assertions or concurrent assertions, how to implement those and how to write the logics. Okay, and next, some of the project which cover some assertions and coverage. Okay, so how practically we can implement in terms of projects, we are going to discuss that thing. And finally, some mock interview questions. Okay, so this is what 8 days schedule. Next 8 days. So what is the date today? 22, right? So next 8 days, it means 16 days, overall 16, 14 to 16 days. So by November first week, we can complete all the sessions. Okay, November first week. So meanwhile, if you have any doubts, there will be regular assignments. You need to work on regular assignments and alternate days sessions. You already know, right? So yeah, that is what. Next, so today agenda. First, introduction to the coverage in system verilog. What is the importance of coverage in system verilog? Not only in system verilog, in UVM also. Okay, commonly we use the coverage, not only in SV. And main goal of coverage in verification. And what happens if we doesn't reach, if coverage doesn't reach 100%? So, what are the uh, what we need to follow to reach 100% coverage, and steps to check the coverage report, and some important questions which are asked in most of the interviews. Okay, so these are what we are going to discuss. So meanwhile, if you have any doubts, please let me know. We can discuss everything clearly. Okay, so first, coverage analysis. Is the screen visible, everyone?
Yes, ma'am.
Okay. So what do you mean by coverage? So whatever you know, just tell few points. What you know about the coverage. Hmm? What is mean by coverage? Why verification engineers use coverage? What is the main goal?
If any bins are not covered in the verification part from the RTL, like any condition in the RTL is missed, any statement or any condition, if not missed, we will be covering those points. We will be attending those things in the coverage.
Okay. What is mean by bin? What is mean by bin? What is the difference between bin and hole? Any other answers from others? No idea?
No, ma'am.
Okay. See, first of all, coverage in the sense in system log it is used to measure how thoroughly our verification environment is exercised, how much functionality has covered. Okay, so to verify that we use the coverage. Okay, suppose as a verification engineer, as a verification engineer or design engineer, we have two types of coverage here. One is a code coverage, another one is a functional coverage. Okay, so code coverage is used for design engineers, functional coverage and toggle coverage, assertion coverage used for verification engineer. Okay, suppose if you go for design, okay, let me explain first what is meant by coverage. Okay, suppose overall, suppose it's a design. Okay, in a design, what we will write in RTL design, there will be a module and module. Inside the module, we will write some procedural assignment statements, or we can write some finite state mission, or we can write some blocking and non-blocking assignments. Sometimes within the procedural assignment statements, we use case X, case Z. These type of blocks we can use, or else a generate block to define for loop. So we write different types of blocks, if else statements, or some continuous assignment statements. These are what we write in the design mostly. Okay, so coming to the verification, that means a test bench. Okay, mostly in the test bench, what do we write in the test bench? Suppose here we written some finite state mission in the design. Okay, so finite state mission or any simple procedural assignment, simple case statement or if else statement, whatever you are writing. Suppose there are ABC inputs. Okay, so there are three number of inputs and there are two outputs, sum and carry. Simple example. So in the design, we are writing a full adder program by using the procedural assignment statements. In the test bench, we are generating some input and input values. Okay, A equal to B equal to C equal to some value, 8 number of combinations. 3-bit means 8 number of combinations it will generate, right? Total. So in the test bench, we are going to write that. So suppose if it is a complex architecture, suppose in the design there are nearly 100 blocks. Okay, so to verify that 100 blocks in the test bench, we need to generate lot of scenarios, right? Suppose here 100 number of inputs. Each input is a 32-bit size. Okay, 32-bit size means how many number of combinations we can check, how many number of scenarios we can check. We can check nearly 2 power 32 number of scenarios, right? 2 power 32 number of scenarios. Sometimes uh, we don't understand, like we don't know whether we covered all the scenarios or not. Verification means we need to cover every scenario, we need to cover every corner case, right? From 0 to 2 power 32, all scenarios maximum, every corner case we need to cover. Okay, here ABC or a three inputs, just a single bit. A single bit means just we can create very easily, but 2 power 32 number of combinations we cannot verify easily, right? So in that case, to cover to verify 2 power 32 number of combinations, we are dividing into the test case, not only 2 power 32 combinations. Inside specification there are lot of control signals, different bus signals. Suppose there will be a write read signal, address signal, data signal. There are 10 number of data signals or 10 number of different addresses. There will be a lot of signals, right? So it is not so easy to verify all the corner case scenarios or whatever the main scenarios, short transactions or medium transactions or large transactions, whatever we are dividing the number of test cases, it's not easy to validate ourselves. Okay, so we can do the verification, but we need to validate, right? We need to check whether we reach 100% verification or not, whether we covered all the cases or not. Okay, so for that purpose, we are taking coverage analysis. Okay, suppose there are two power 32 number of different scenarios out there. Okay, so we are writing 10 number of test cases. Okay, 10 number of test cases to cover that 2 power 32 scenario. Maybe it's address or data, some other signals, whatever. Okay, so we are writing 10 number of test cases. In this 10 number of test cases, how we do the verification? We need to run the test case. If test is pass, so that functionality has verified. If test is failed, the functionality is not verified, right? So for 10 test cases we can check easily manually, but in industries, if we go with SOC level verification or any IP level, there will be thousands of test cases will be there. Okay, we need to verify thousands of test cases in every small block. So in that case, if you want to check every case, every functionality is verified or not, if we want to check, that is very difficult task. Okay, we need to run all thousand number of test cases. We need to check whether all are passed or not. In fact, if tests are passed, we don't know whether it is reaching proper functionality or not. Okay, maybe the test case is some other functionality, right? We don't know whether it is reaching proper functionality or not. Okay, so mainly to check all these things, we are writing the coverage. Okay, so coverage is nothing but it's a small program, like in oops concepts. However, we use some inheritance, like in randomization or constraint, constraint, right? So however we return the constraint, coverage is also a small piece of code where we write some bins. Okay, bins, we call it as a bins means what? Suppose here 10 test cases are there. Okay, so I need to check whether these 10 test cases are reaching its a functionality or not, whether all test cases are uh, reaching its like whether it is hitting all the bins or not hitting all the bins. In the sense, we are writing some values. Bins are nothing but some values. Okay, suppose 2 power 32 values are there, we will create 2 power 32 bins, or we can divide into some bins. In one bin we can write for 10 bits, next bin 10 bits, like that. Okay, no need to write 2 power 32 number of bits. In the next session you will get the clarity. Okay, so to verify that whether we reach total functionality, whether all the functionality is verified or not, to check that, we use the coverage analysis. Okay, so whether it is a code coverage or functional coverage. Code coverage means we write for design. Functional coverage means we write for test cases. Okay. So everyone got the clarity?
Prashanti, can you repeat that last
Yes,
2
ma'am.
points?
Code coverage is written for design, RTL design. Functional coverage is written for verifying the test bench. For test bench. In to verify test bench, we write two types of coverage. One is a functional coverage, other is a toggle coverage. Okay, toggle coverage is just to check toggling operation like a 0 to 1, 1 to 0, it reach or not. Mostly, okay, anyway, in bins we get the toggle coverage also. There I will explain. So everyone got clarity, basic clarity, what is mean by coverage? Just whether we met the design functionality or not, whether we verified the total functionality or not, to check that we are using the coverage, to check that we use the test benches. Okay, so whatever the test benches we have written, whatever the tests we have written, whether they are doing its operation or not, whether they are used to hit all the functionality or not. Okay, so to verify that, we write the coverage. Okay, everything clear? You need to understand the difference between design code. For the design code, we are writing the test cases. For the test cases, we are writing the coverage. Okay, so to verify the design functionality, we are writing the test case. Okay, to verify whether all the test cases meet the design functionality or not, to check that, we are writing the coverage. That is the difference. Okay, is it clear from everyone?
Yes, ma'am.
Okay. So if you observe here, a small block diagram. First, verification plan. We need to take a verification plan. Whether you are working with a small project or any complex project, whatever, verification plan is very important. Nothing but plan in the sense, how many number of like in the design, how many number of blocks are there, in every block how many number of test cases we are writing, which test case will hit, I mean, which functionality is going to verify by some test case. Okay, if there are 10 number of test cases, every test case have its own functionality to verify its own functionality, right? So we need to make some points, okay, that usage of that particular test case. And also some test ID. If we go for some industry, there will be some test ID and regarding suit names. There are different types of names will be there. Okay, so that is what verification plan. After verification plan, we create the initial coverage metrics. We create the initial coverage. That means we create some bins to hit the coverage, bins to hit the test case. Okay, and generate random tests. We need to generate the random tests according to our scenario. We write the constraints, right? Based on the constraints, it will generate some random values, random tests. So for that, we do the coverage. We write the coverage. After after test run, collect the coverage. At same time, we collect the coverage. So if coverage goal meet, what is the goal of coverage? How much percentage in any project? What is the percentage of coverage goal?
100.
100%, whether it's a small design or any SOC level or IP level, whether you are doing in SV verification or UVM verification, whatever, our goal is 100% coverage. Once it reach 100% coverage, then we can confirm that our design is 100% verified. In every corner case scenario, our design is 100% verified, so that we can send to the backend process. Backend is a physical design process, right? The post silicon process. So we can send to the backend. Okay, so that is what the coverage verification engineer. So when we can confirm that verification engineer task is done, when can we confirm? In the sense, once we reach the coverage 100%. Okay, so that's why coverage goal meet. If it meets, S, verification is completed when it reaches to 100%. If no, we need to identify the coverage holes. Holes are nothing but which are not hitted, bins. Okay, suppose I told here there are 10 number of test cases. Okay, in real time there will be nearly 1,000 test cases, one single block for one suit. There will be thousands of test cases. For thousands of test cases, we will write lakhs of bins. Literally, there will be lakhs of bins in the coverage. Okay, so we need to hit all the bins according to our test report. Okay, so if there are 100 number of bins, all 100 number of bins need to hit in the sense one. Okay, not hit in the sense zero. Like test is pass means one, test is fail means zero. What we need to do for fail test? Again, we need to check where the test is failing. We need to do debugging. We need to fix the errors. Okay, so so after that we can get the test passed. So we need to do debugging. In the same way, bins hitted means one, bins not hitted means zero. Okay, so these whatever the zero bins are there, we call those as a holes. Okay, that is what difference between number of bins hitted and holes. So we need to identify coverage hole, that means which are not hitted. Okay, so after identifying the hole, we need to add the test to target holes or enhance a simulate stimulus generator or enhance coverage metrics if needed. Okay, why the bins are not hitting? Why do we get the hole? Because the test is not passing. Okay, if test failed, then also we cannot get the coverage report, right? Because bins will not hit if test is failed. Okay, test failing means it doesn't do its functionality, it doesn't verify anything, right? So if it is not verified, coverage will not reach, coverage will not increase, right? Suppose if there are suppose if there are 1,000 number of test cases, in the 1,000 test cases, 600 test cases are passed. Okay, 600 test cases are passed, 400 test cases are failed. Okay, so in that 600, after tests are passed, we need to extract the coverage. We need to upload the coverage and we need to extract the coverage. It totally depends on what simulator we are using. There are different simulators, say Synopsys or GVim or any tool. Okay, Cadence or EDA Playground, whatever. Every simulator have its own commands. Okay, if you go to industry, there we write commands. Why? Because whatever the block we are using, whatever the design block we are using, based on the source, based on the test case, based on the test ID, we will create some commands. Okay, no need to worry now. Anyway, you will get the basic commands from these sessions. But every company have their own commands. Okay, so no need to worry now. Once you go to some project and all, there definitely you will learn these things. Okay, if you get some coverage related work. Okay, so here if there are 600 tests are passed, so coverage report will be around 60%, not exactly 60%, around 50 or 40% or 60% like that. Okay, so is it sufficient to reach the verification goal? It's not sufficient, right? So we need to increase the coverage by to 80%, 90%, 95%, even 99% also not correct. Okay, we need to reach 100% exactly. Okay, so for that purpose what we need to do, whatever the failed test cases are there, we try to fix the error. Whatever the error is getting from the test case, we need to fix, we need to debug, then we need to pass one by one test case, so that coverage will automatically increase. Okay, did you understood everyone? Suppose in the next milestone or in next regression, 300 tests are failing, that means 100 tests are passed, so coverage will reach 70%. But is it sufficient? No, still 300 tests are failing. Maybe in the next after some regressions, 200 tests are passing, and 800 tests, sorry, 200 are failing, 800 are passing, so coverage reached to 80%. And next regression, 100 tests are failed, so here nearly 900 tests are passed. Okay, so like that, coverage will be increased one by one. Okay, sometimes even 1,000 tests are passed. Okay, there are 1,000 test cases, all 1,000 tests are passed, but still coverage doesn't hit 100%, maybe at 95% or 98%, sometimes 90%, it will stuck somewhere. Okay, it doesn't reach 100% coverage even all tests are passed. Okay, why? Because nothing is there. Maybe we written some extra bins. Okay, to hit the test we have written some extra bins, so we can remove those bins. Okay, that is a one case. Mostly there will be some extra bins or unused bins will be there, so we can waive off the uh, extra bins. Okay, so that is what different variations in coverage. Everyone understood now? Do you have any doubts?
Prashanti, have a doubt. Uh, Suppose for we have like design specification, we created like 10 test cases for the design specification, or like based on our study, and created coverage metrics for those 10 test cases, and we got 100% coverage. It doesn't mean like we verified all the design specification corner test cases, right? Only we created like based on our study, we just created 10. So there might be other test cases we need to create. How will ensure like complete
See,
design corner cases will be
um,
verified?
first of all, as you said, design, okay, specification is there. In that specification, every scenario will be mentioned, right? So you
Yeah.
need to write all test cases according to that scenario. Suppose there is a design. For to verify this design, we can write 100 test cases, we can also write 10 test cases, we can also write one. Okay, so how we can how we can check whether total functionality is verified or not? Whenever we are writing very clearly, that means to verify every corner case scenario, then we can reach every functionality. Okay, you can close the same design with the 10 test cases or 5 test cases also, but it is not a main, right? So we need to check first of all how many tests are required. So if you want to close in 5 tests means it's up to you. Okay, based on that we write the coverage. So 5 tests hitted means coverage will get 100%. But still your functionality, main functionality should verified from test case. So that is a verification engineer main goal. Once you write all test cases, then you need to write the bins. Did you got my point?
Yeah.
Is that your question?
Yeah, during my project implementation, I
Hmm.
faced issue like even the design specification is given. I've missed out like very corner test cases to create, so I just had a doubt.
Mm. Okay, first we need to write the test cases for all. Then we need to go for coverage. Whatever the test cases we are writing, for that only we will write the bins. Okay.
Okay.
Yeah. Next, so everyone know how how to design system verilog architecture and UVM architecture, right? So this is a small example how the coverage is used in UVM verification. Okay, see here. There is a register sequence library. In UVM, we have sequences and sequencer and sequence items, right? So library in the sense all sequences will put in one library. There are multiple number of sequences are there. So we put all sequences in one library. Register sequence library means it's totally related to register memory related. Okay, registered transactions. There will be normal transactions and the memory related transactions, right? For memory related, we use separate concept in UVM, that is a RAL model. Okay, so to verify particularly registered, so we use RAL models concept, right? So these are register sequence related and custom sequences means normal for all the basic signals, and VIP sequence library. Okay, here there are some VIP related sequences. Okay, so first in the agent you already know the sequencer, driver, and adapter. Adapter is nothing but it's a basic building block for register. Adapter is used to convert register data to the binary data to register data, right? So that is why we use the adapter. In normal UVM we don't have any adapter, we have a sequencer, driver, and monitor. Okay, and here register model in the sense what is the size of register, and what is the width, depth, and what is the configuration of register, like that register model, and model updater, and signal interface driver, and checker is nothing but scoreboard. Okay, so in the scoreboard we write some reference values and we generate the output, right? Expected values and original value, main values. So checker is nothing but scoreboard, and configure. So config DB in UVM, you already know the config DB. Just to customize the different. Suppose if you want a scoreboard enable, or if you want which type of agent, a passive agent or active agent. Or anything we can customize in a configuration DB. So in that, coverage collector is one of the separate block. So if you see all agents, and here signal drivers, and here registered models, everything is connected to coverage collector. Okay, so here we write the different number of bins. Based on the bins we verify the test case. So whatever the tests are passing, based on that we bins are getting hitted, so that coverage report will be increased. Okay, so this is what circulation, all everything in a circular manner. Okay, writing the test case, whether the test is pass or fail, uploading the coverage, extract the coverage report, and check the coverage. Whatever hitted bins are there, okay, whatever not hitted bins, nothing but whatever the holes are there, just go through what are the holes and check which test cases will hit for that holes. Okay, so you need to work on the test cases, whatever remaining holes are there, you need to work on those test cases. Okay, so this is what exactly happened in real time. Okay, clear everyone?
And one more doubt. For a design, if we have like a number of test cases, is there any order that first we'll be running specific like functional verification test cases, like next we'll be focusing on other corner test cases, all will be together.
No, nothing like that. See, in test cases also there will be different types in the sense, some test cases will run fast. Okay, in 1 hour it completes its simulation. Okay, fast running test cases will be there. Slow run test cases will be there. Some test cases will run for 2 days. Some test cases for 1 week. Okay, in SOC level. So whatever tests are passing first, they will we do the verification first. They will hit. Okay, like that. Whatever first whatever tests are passed, so automatically they get hit. We cannot tell only this test case need to hit first, and it's not like that. Anything based on its a time simulation time. Okay,
Okay.
yeah. Any other doubts? Okay, others. Gurushant, Padmakar, Pragati, Vittam,
No, ma'am.
No, ma'am.
Divya, Chakravarti, Mohan. No doubts. Okay. Okay. So next types of coverage. So what are the different types of coverage are there? So first is a code coverage. I already told, right? What is mean by code coverage? Mostly code coverage is used by design engineers, okay, RTL design engineers, mostly to measure the structural coverage like a branch, conditions. I told if else statements, case, FSMs, procedural assignments, continuous assignments. Okay. So generate blocks, blocking assignments, non-blocking assignments. So all these things comes in a design, like loops, different loops are there. So if we do the verification, that is a code coverage. And functional coverage. Functional coverage is nothing but it is used to measure all the functionality has been tested based on user defined goals by verification engineer. Whatever the test functionality is there, whatever the design functionality is there, the design functionality we verify using test bench. So for that purpose, we use the functional coverage. Next, assertions coverage. In system verilog, we write the assertions to validate the design. To validate the design means suppose there is a clock and reset. Okay. So you are telling like there is a shift register. Okay. In the shift register, the clock should high at every shift of data. Like every positive edge of the clock, the register is shifting its data. Serial in, serial out is there. Okay. So for every positive edge of the clock, one by one bit is shifting. Okay. So to validate that whether it is shifting properly for every positive edge of the clock, to validate that we write some assertion. Okay. So whatever the assertions we written, whether all assertions have been evaluated or not during simulation. For that purpose also we write the coverage. Okay, but mostly we don't use in normal cases. Maybe in industry we use the assertion coverage. Okay, so these are the three different coverages. Everyone understood? Clear up to here? Next, importance of coverage. So you already know what is the importance of coverage, right? So can you tell me anyone what are different usage of coverage? Hmm? Okay,
It
first what
ensures the quality of our design.
quality of design? Okay, It provides quality and quantitative also. Okay, quality and quantity. So first of all, improves the verification completeness, whether we do proper verification or not. To check that, we use the coverage. Okay. Some not only based on the test, based on the functionality also we write the bins. Okay, mostly. If you write based on the test, okay, suppose as she asked before, Nitya, there is a design. Okay, so she written only 5 test cases for the design, but actually we can write 10 test cases or 20 test cases to verify total design. Okay, so in that case, if you are writing 5 test cases to verify a design, for the 5 test cases, if you write the coverage, what is the use? What about remaining functionality of design? Based on the coverage report, uh, we need to modify the test cases also. Are you getting my point? Suppose I will show you for detail. This is my design. Okay. So to verify this design, you are writing these many tests. Okay. So our main goal is whether actual functionality of design is reaching or not. Okay. Total functionality is verifying or not. So general basic idea. I'm just giving basic idea. Suppose if I write the coverage for this test, anyway, we get the 100% coverage. Only for this test, we get the 100% coverage because there are only 5 number of tests. 5 number of tests are covered, we get 100%. But we never write only for number of test cases. We need to write based on the functionality of actual design also. Okay. So if you write actual functionality of the design, based on the functionality of design, you are writing the coverage. Okay. So even if you write only 5 test cases, okay, our coverage report never get 100%. We'll get only 50%. Okay. Now you will get the idea, okay, where I am missing that 50% coverage, what I need to do now. So you will get the idea, okay, I need to cover this all scenarios also. Based on that, you will increase the test number of tests, you will increase based on that. Okay, so this is one case. Did everyone understood? Did you got my point, everyone? Not only based on test cases, whatever we have taken, based on actual design functionality also, we need to write the bins so that you will get understand how much test is actually verified and what test cases need to add, what are required test cases to hit remaining functionality. Is it clear, Nitya?
Yeah, I got the clarity.
Okay. So that's what improves verification completeness. So to ensure that all design features are tested and reducing the undetected bugs. Okay. And next, guides test bench test development. Okay, guides test development means, as I told, coverage helps the verification engineer to identify the gaps in the test bench. Okay, and it direct them to create some new tests to cover the missed scenarios. Okay, so based on design functionality, we get that thing. So it guides the test development. What and like which whatever tests are missed, you can recreate those. Okay. Next, key for verification closure. So that is main important thing, right? Because it reached the coverage metrics. It plays a crucial role in determining when the verification is complete. Okay, so verification closure, and it boosts the confidence in design. That means if high coverage level provide the confidence that the DUT will work as expected across the wide range of scenarios. Okay, so whenever the coverage is meeting the goal of design functionality, we get the confidence. Okay, our design is meeting the expected verification. Okay, so that is what main importance of coverage. Next, optimization for time and resource. Mostly it identify which part of design is not covered. Okay, that is a main important thing for verification engineer. Suppose okay, we written five number of test cases, five number of tests are passing, but we don't know which scenarios are not covered. Okay, so based on the bins have some names, right? So based on the names of bins, we can identify, okay, this corner functionality is not tested, so that we need to put some test case related to the functionality, so that we can hit that functionality. We will get some idea. Okay, so that is the main thing for verification engineer. So it provide the resource to identify the whatever not hit functionality is there. Okay, I think everyone got clarity. And next, what is the main goal of coverage in verification? Okay, so what is the main goal? It maximize the test coverage. That means the main goal of coverage is verification to ensure that all aspects of design have been verified in test bench or not. Verifying both structure wise and also functionality of DUT. Okay, code coverage means mostly we check structure. Okay, structure means what? There are else if else. So to verify that structure, we use code coverage. Like that procedural assignment is there, continuous assignment is there, begin and block. To ensure that structure, whatever the begin and block, fork join, or blocking, non-blocking assignment is there. For that purpose, we write the code coverage. But internal functionality, whatever there, okay, between where inputs and outputs there is some functionality, right? To verify that, we use the functional coverage. Okay, so it maximizes the test coverage and minimize escaped bugs. So while we are verifying the tests, there will be some pass tests and fail tests. So based on the fail test, we get some bugs. So whatever the bugs escaped, we can find out those easily based on the functional coverage, right? Because bins are not hitting, right? Even tests are passed, bins are not hitting. Bins are not hitting means whatever unknown cases are there which we can't identify at top level. Okay, so internally there will be lot of signals. Okay, so those signals also we can identify by using bins. Okay, so whatever the escaped bins are there, internal signals, those errors also can be captured easily by using the bins, because bins not hit it. Okay, next, efficient verification process. Anyway, it's efficient, right? Because coverage meeting the goal of verification functionality, in the sense it's very efficient process. Okay, so it ensure all unnecessary tests or redundant tests, it run everything, so it's work effectively. Okay, next, functional coverage versus code coverage. I think you already got the clarity. Can anyone explain what is the difference? Functional coverage versus code coverage. Goals.
Functional coverage is how much functionality of the design is verified. Code coverage is how much code is being exercised.
Mm, okay. So, yeah, that's what. Okay. Next, steps to check coverage report. As I told, to check the coverage report, every simulator have its own commands. Okay. Process is same everywhere. What is the process means? First, we run the regression. What is mean by regression? Do you have any idea what is mean by regression?
Regression will run the test cases.
Regression will run test cases. Okay.
Running multiple test cases, like thousand of test cases at the same.
Mm. Okay. So we run all all test cases at one time. Okay. So suppose there are 2000 number of test cases. Okay. So to run 2000 number of test cases individually, each test case, it takes lot of time. Okay. So by using the commands are nothing but we are learning scripting, right? Perl scripting or Python scripting. Okay. Mostly we use Perl scripting for verification. Okay. So by using that commands, we create some commands to run. Okay, so to run the regression or to run the coverage or to run some internal, there will be lot of boot up. So running different suits, there internal there will be lot of things, right? So for that purpose, we create some commands by using the scripting language. Okay, so in that way we create some command to run all 2000 number of test cases at a time. That's what we call as a regression. Okay, where we check how many tests are passed, how many tests are failed, what is the name of the test. Okay, what is the test ID, which block the test is related. Okay, which suit the test is related, and what is the error. Okay, what is the error and what is the path of the error. Not only telling what is the error, it should tell where the error is getting, which path the error is getting, right? So all this data we get in a server. Yeah, like there will be some, every industry, every company have their own servers, right? So there we get the report like this, regression report. Okay, so test ID, name of the test, what is the block related, suit related. Okay, next, whether test is pass or fail. Okay, and what is the error and where the error is getting. So we get all the data so that we will we can make differentiate like passed test cases one side, failed test cases one side. So we check the error, what is the error for failed test case, and there will be path also. We just copy the path and we start the debugging process. It's a just very complex thing. Okay, we do the debugging process. So this is what we run, how we run the regression. Okay, so after running the regression, whatever the tests, past tests are there, for that we upload the coverage by using same commands, same scripting commands. We write how we write what is the test name, or if you want to run all tests in a one at a time, we write some suit name. Okay, which configuration it is. Okay, configuration in the sense in SOC level, in SOC level, there is a processor. Inside processor there will be cores, right? There will be graphic processors, north bridge IO, south bridge IO will be there, AXI related signals will be there, PCIe related signals will be there. So core means core related configuration, it will work in that configuration only. Okay, so AXI signals means it have some configuration, AXI related configuration. So all the test cases will put in the AXI related configuration. All core test cases we put in a core related configuration. All PCIe related tests we put in a PCIe configuration. All North Bridge IO or South Bridge IO or data fabric or graphic processor related. Okay, there will be lot of things. So everywhere we put some configuration. So within that configuration, we will mention all test cases, whatever classification, like classification. If there are 2000 test cases means we need to classify, okay, which are related to which config. Some are related to PCIe config, AXI config, NBIO config, Southbridge IO, data fabric. So we need to divide like that, so that while running it is very easy, to debug also it is very easy, and all the test cases will not run with by same person or same team, right? There are different teams, these test cases one team, these test cases like that, there are lot of teams. So that's why we will divide like that. Okay, so how we write the coverage command? So we mention the test name or suite name, configuration name, and test related things will be there, right, inside the suite. So in that we put all the command, all things in the command. So we run the command. First we extract the coverage report. First we upload the coverage. Then we extract the data. Extract the data in the sense how many number of bins hitted, how many number of holes. So this is a total idea. Okay, everyone clear? Actual what industry in what happens in the industry, same. Okay, clear everyone up to here?
Yes, ma'am.
Okay, see here. First, enable the coverage. You can go through the theory part, run the simulation, same whatever I explained. Generate coverage report. So for synopsis, we have some command. Mentor Questa, we have some commands. Cadence, different commands like that. So analyze the code coverage, functional coverage, coverage holes, and improve the test coverage. So these are what steps to coverage, check the coverage report. Okay. And next, question and answer discussion. So everyone clear? Any doubts still here for today's session?
Ma'am, then what is meant by toggle coverage, ma'am?
Toggle coverage means, see, just toggle coverage, we check 0101 cases. If a reset is high, so in the next clock reset is 0 or not, like that there will be different signals, right? Well, at particular, a toggle means every time it doesn't do toggle, at some point of time only it do some toggle operation, right? 0 to 1, whether it is changing or not. So at that at that simulation time we check whether it toggling or not. We have the bins also. Tomorrow, in the tomorrow session, we'll create some bins. Okay, there you will understand.
Okay, ma'am.
Yeah. Any other doubts? Others? Okay, so can you tell me, can you answer for these questions? What are best practices to achieve high coverage? What are the best practices to achieve high coverage?
Understanding the design specification very clearly and creating test cases for all corner cases and writing coverage matrix for all those covering bins for those all test cases.
Okay. What happens if coverage doesn't reach 100%?
If any test cases fail, we need to focus on the target hole and recheck the test cases and writing the bins again if anything is unheated.
Okay. Others? Next question is for Padmakar. What is code coverage and how it is differ from functional coverage?
Code coverage is used by design engineers, ma'am. In that they'll check each and every code and they'll exercise it. But in functional coverage, we'll be writing different test cases and checking the functionality of each variable. It is doing its work or not.
Okay. So based on test cases, do we write the coverage report or based on the design functionality?
Based on the
Based
design
on design
functionality.
functionality.
Based on design
Design
functionality.
function. Yes.
Okay. Whenever you are answering for interview questions, so these are very important things. Okay, remember. Next, how do you measure the effectiveness of a test bench using coverage metrics?
Depending upon developing the test case development and covering the corner scenarios.
Okay. What is the significance of achieving 100% coverage? Is it necessary?
In some conditions, it needs 100% coverage, but in some conditions, we don't need 100% coverage depending upon the design.
Okay, so in what conditions 100% coverage is not required?
In, for example, end case we are using, right? In that scenarios, some end cases, if inside the else statement, we don't need. So that else statement won't be covered.
In functionality coverage, functional coverage.
If you miss any corner scenarios or any condition,
Do we need 100% coverage or not in functional coverage?
yes, we need 100% coverage.
Okay. Okay. So Diptan, hi. Can you tell me what is mean by regression and how the coverage is extracted?
We merge all the test cases into
I
one.
I asked for Diptan. Yeah, please tell. Hello. Fast. Chandana, can you answer? What is mean by regression and how to extract the coverage report? Chandana. Pragati, can you answer? Chandana, are you there? Diptan, are you there?
Yes, ma'am. I'm there.
Then answer. Hello. Okay. CB, can you answer?
Ma'am,
What is
Regression means
regression? Yeah, Pragati.
uh, re- regression means we are combining all the test cases that we require for the design.
Okay. Next, how can we extract the coverage? Okay, that's it. Everyone practice. So I will be sharing the session and PDFs on code coverage and then functional coverage. Okay. Okay, then thank you all. Bye.
Thank you.